Hey everybody, welcome back to the shop. Quick little video tonight. I've got a Jeep JK in the shop who the owner was experiencing death wobble. Now, there's a lot of things that can cause death wobble. Generally, or probably most common, is track bar bushings or track bar holes elongated out in either the axle. Generally, it's the axle side. Seldom is it the frame side. This one in particular had both of them, and the frame side was actually worse than the axle side. I have not seen that before. All the ones I've done in the past, it's always been the axle side is the worst, most damaged one. Now, I thought I'd document this one just because of the fact that this Jeep is 100% stock. It doesn't have large oversized tires. It doesn't have all those things that exacerbate death wobble and the wear characteristics that go along with having oversized tires and suspension systems and everything. So anyway, I want to show you how I choose to go about repairing these. I've repaired, I don't know, 12, 15 of these things over the years now. The way I do it is a little more invasive. It costs a little bit more, but in my opinion, it is the ultimate way to properly fix these holes to where you're not going to have a problem again, and it's not going to be a Band-Aid repair. So let me bring you in closer and show you what we've got, and then I'll take you over to the bench and show you how what the setup looks like before it goes into the brackets. So this is how I repair them. I machine weld washers, but the weld washers are actually stepped. So you have the thickness of the original frame bracket, which is about 1/8 of an inch. I think they're 10 gauge, so it's about 125, 130 thousandths thick. And then I add another 125 thousandths to it. So this is basically 1/4 of an inch. Now just over 260, so about roughly 1/4 of an inch thick of surface area that the fastener is now going to have for support. Now, I've seen people, when these use the term weld washers, I've had some of these come in, and I've seen some of them out there where they literally just take a washer and weld it to the elongated hole. Please don't do that. That is a half-assed Band-Aid way of doing it. Number one, a regular washer, I don't have one that's 5/8, there we go, has got so much slop on it that you might as well just use the elongated hole, number one. And number two, the washers are generally thinner. Like that one's a pretty thick washer, but that one's only 100 thousandths. So your washers are thinner than the parent material that the hole's elongated. So when you put a washer up there, you've got thinner material than you started with, and then the elongated hole is not adding any support. So I will usually go in and kind of scribe a circle and try to keep it as I don't want to take away any more material than I have to, but I will scribe a circle and then rotary bit it out to get it back round, and then I will ream. Like this particular one, I ended up going to 3/4. So the ID of the step measures 750 thousandths. This goes into that, it gets pressed into that hole and then welded around the perimeter on each side. Now you have 1/4 of an inch and 1/4 of an inch of material to support it. Now, where I also vary on weld washers is the ones you buy, like for if you're building the suspension and everything, and they make commercially available weld washers. So you have a piece of plate. Sometimes in race cars, stuff like that, we call them doubler plates. Oftentimes, if you're just doing one hole, you just use a weld washer, and it's basically just like it sounds. You weld, you have a machined hole. It's not just a regular drill bitted hole. You want to make sure the hole's good to start with, and I prefer reaming. So you've got a reamed hole, you've got a reamed or machined weld washer, and it goes on, and then you use a precise, either a pin gauge or some kind of drill rod. I use drill rod quite a bit to line them. Then you go ahead and weld the perimeter. Now you've got the bracket plus the weld washer material giving you the strength. Well, with an elongated hole, you don't have that original plate, so therefore you want to be able to go inside of that, which is what I machine, press them in there, and then you're good to go. So the next thing is this fastener selection. If you choose a fastener, just a standard fastener based on what you go buy at the hardware store, you're going to end up, I needed 2 1/4 inches from outside. When this is in the bracket, it's 2 1/4 inches from outside to outside. So you need one with a grip range of 2 1/4 inches of the shoulder. You can alter the thread length. You want the shoulder to be 2 1/4. So therefore it sits fully on the shoulder and you have no threads contacting that weld washer. Because if you do, the threads are gonna, you're only catching the tops, those threads are gonna beat into it, and pretty soon you're gonna damage the threads, reduce that, it's gonna end up walking, and you're gonna be right back to where you started again. So fastener selection is just as important. You want that shoulder fully on. You can tell a difference even just right there on the threads, how loose it, I mean, it's not loose flopping around, but it's definitely not a tight fit, and then as soon as you go onto the shoulder, you can tell a difference. So that right there measures my 2 1/4 inches, right, actually just, yeah, right, pretty much right on the money. Now, if you have any, like let's just say, for example, you come in there and you had just maybe half a thread, then you can go ahead and add a washer to take up that and put your nut on, so you actually tighten it down tight. But you don't want threads to engage with the weld washer. You want that fully supported by the shoulder of the bolt. That, in my opinion, is the proper way to fix these, or any holes for that matter. I've done it on sand rails, I've done it on ATVs, snowmobiles, Jeeps, a lot of Jeeps. So keep in mind, this is just the way I choose to fix these. If you're gonna do it right. If you just take a washer and weld that on the side, it's a Band-Aid repair, number one, and number two, the next guy who's gonna have to fix it properly is gonna have a bigger mess on his hands. Trust me, I've had to fix a few that have come in with a washer welded to the side, and it's a pain in the ass, and it ends up costing you more frustration and definitely more money, because if I gotta go through and fix something that somebody else has done improperly, it carries a heavier price tag. This is not an inexpensive repair. It's not a bad repair. You can do one in a few hours. By the time that's machining the specific bushing for that vehicle and everything, but this is a permanent repair. This will outlive the vehicle. As long as that fastener stays tight, this will outlive the vehicle. Let me take you back over to the Jeep, and I'll show you the frame side that I've already got done. I hope this shows up. There's the 2 weld washers welded in. They're pressed in, and then I've just TIG welded around them. And then here's the bolt that I've already trimmed to size, so it will go into the hole. It'll go through the track bar, and it'll have a nut. And then I cut the threads back, so once the nut is on, there's only 1 to 2, maybe 3 at the most, but I usually try to shoot for about 2 threads is all sticking out, protruding past the nut. I don't like a lot of threads sticking way out past, like something like that. So anyway, that's the finished product. That's what they look like. This will get touched up with some chassis paint and everything back together, but this is, in my opinion, the proper way to fix these and not have this issue repeat itself. So I hope you find that this is just a short little quick video. I hope you found that helpful, and I appreciate the comments. Thank you.